everyone. Thank you, Jeremy, and thank you, AI for the Planet, for hosting us tonight for this special edition of Powered by AI. So we're going to talk about the impact of AI on climate change, on sustainability, on the energy transition. So we've seen a lot of discussions around use cases where AI can help industries be more sustainable. We've also talked a bit about the impact of AI on sustainability, but we're going to get into the weeds. And thanks, Arnaud, thanks, Theos, for being here tonight with us. We're going to discuss a bit about the impact of AI, both positive and challenges that we encounter. So it's been almost 2 years now that generative AI has come out in the spotlight with ChatGPT. And almost daily since then, it's in the news, AI is in the news. And recently, on my news feed, there's been a lot of discussions on very interesting things that came out. And one of them is, for example, OpenAI that launched GPT-01 that does reasoning with very complex AI. So maybe let's start with that. And Theos, I'll give you the hand to explain to us a bit about how AI models impact sustainability and what the energy requirements are for these new models.
Thank you, Mihir, and pleasure to be here. Thanks for putting this together. First of all, we were discussing before, lots of the use cases, if not all, we heard so far are not Gen AI, which is interesting, which says something about either the energy-related space or sustainability-related space, or the overall adoption, diffusion of generative AI in the economy in general. So we may be early days, so it's interesting to observe this. Now, going back to your question here, it's we also the announcement a couple of days ago from OpenAI. What's one interesting observation here is, of course, something that was also tweeted a lot, which is how the balance of compute between training and inference. So the training used to be like where everything was happening in terms of compute, and inference was relatively fast, has changed. So now there is inference usage when you use large language models or whatever, Gen AI in general. When you use it going forward, that will also consume a lot and require lots of compute power. Because the objects, I use the word objects intentionally, just, or the things, if we use the Internet of Things kind of language, that will be using Gen AI to communicate with you, so you communicate with them, will need to think. And thinking, will consume energy. It needs compute. Now, this has implications about where is the compute sitting. It's not sitting anymore only where the training is happening, but it has to be sitting locally and where the inference is happening, which of course means it can be good and bad at the same time. On the good side, you can distribute it, and we'll come back to this later. So this is something to watch, how much compute and therefore energy needed at the usage versus at the training part. That's the biggest change probably. But having said this, we also talk a lot about how much energy AI uses. Of course, we can also talk a bit about how AI can help with the energy potentially transition. We've seen some use cases already, but we can talk about later also about the usage of AI in the energy sector itself to make it more efficient or better run or whatever.
Yeah, that's interesting because, for example, another news article that came out recently is in The Atlantic by Karen Howe about how a big tech company is using AI to help their sustainability mission, but at the same time powering companies that drill for fossil fuels. So how do we deal with those two kinds of use cases in the economy? Do you have something to add about the sustainability aspect of AI?
Yeah, I think there is one thing that is important. We are talking a lot about AI in the use cases, in the way we use it. Behind all of this, we have workloads, IT workloads, and digital infrastructures. All these new technologies, all these new AI chips from NVIDIA and the rest of the world are changing the game. These are changing the way we should see the data center space. So we have the general purpose cloud and the general purpose data center, and we need to think about new types of AI data center called AI factories. Because all of these workloads will increase in terms of computational and advanced computing power. And we are seeing, like Jensen Huang said, I think a year ago, today AI will generate tokens. So we are very close to the industrial revolution where we have issued a couple of hundreds years ago the electrons out of the atom and the vapor. We came out with electrons. And at that time, people didn't imagine really what they're going to do with electrons. Today, everything is electron. Everything in our life, we are using electron on a daily basis. Token, it's exactly the same thing. Floating point numbers. This is what is getting out of a workload from an AI computation process. So we're going to use floating points numbers, so tokens, in our life on a day-to-day basis without knowing that we are using AI. And it's already a little bit the case. Talk about Copilot, talking about Gemini, talking about all of these technologies are using AI workloads. So we need to think about how all of these workloads will run on a new type of architecture, on a new type of data center that won't continue what we have started with the general purpose computational data center. Otherwise, we won't be able to feed all of these workloads with the total amount of power available on Earth.
So that's interesting that you talked about the electron, because ENGIE's mission is around combining the electron with the molecule. And we like to think about it from the AI perspective as adding the neuron to it. But then the token is possibly the smallest element of what AI is going to be about in the future. So Theos, you were talking about use cases that positively impact climate change and sustainability. Do you have some examples from your previous work with companies like E.ON or ENGIE?
Yeah, so as we said before, it's important to also think about how AI can be part of the solution. There are lots of use cases in the energy sector. We've seen this in a couple of projects we've done with large energy companies in Germany, as you mentioned, E.ON, but also ENGIE. Think about everything from, let's say, weather prediction to optimize the production of let's say, wind energy or solars or whatever, to also make strategic decisions about where to allocate assets. Asset utilization and management optimization can all be helped with these technologies. You can think about it also parts of the value creation which are kind of quote unquote hidden, like energy markets, where you can actually kind of optimize in a sense the market structure itself with the data with non-generative AI. But also think about predictive maintenance, which is a big issue. I mean, you have been doing some very interesting work with robots and drones going around. I mean, I've watched some amazing videos from ENGIE on drones running on top of windmills. I'm curious what else you are doing. I'm sure you're doing lots of stuff over there. So which can help with predictive maintenance in order to, again, optimize the downtime in this case, optimize, and in general, optimize supply and demand, of course, right? Both the supply and the demand, and the supply and demand forecasting, and the supply and demand matching. Yeah, so I'm very curious also what you do latest. Then, of course, Mihir, maybe you can share whenever you like some of that stuff.
Yeah, that's interesting because we with my team, we were traveling to Chile last week to explore how drones and robots can help with visual inspection of high voltage transmission lines, for example. And that's something that's being done in the industry that we're moving further in terms of computer vision and identifying defects and anomalies. And what that reminds me of is that a lot of the use cases that we work on is traditional AI. It's computer vision, sometimes natural language processing, a lot of time series and machine learning models that are not that data heavy or that compute heavy compared to generative AI. So we have one use case that is specific to generative AI in my team, especially where we work on identifying stakeholders and their positions towards infrastructure projects, because there's a lot of discussions around new power plants in territories, how they're going to be accepted by the general public. So generative AI can help in that. But a lot of the Gen AI use cases we have in the company are functional. So Arnaud, how do you think about this combination of traditional AI and Gen AI?
Well, I think for me, just workload. So the type of workload that we are trying to use today, clearly in Gen AI, with these new big training clusters, we have to generate and to use new types of hardware. So we have seen in the past month, NVIDIA launching new GPUs. These GPUs are here to try to increase the computational power of one CPU and maximize the efficiency of that, just to avoid piling thousands of CPUs the way we've been doing that in the past. So these new GPUs are bringing digital infrastructure at scale. Just to give you some numbers, to train the OpenAI, the GPT-4 model, they need probably 16,000 GPUs. This cluster is about $1 billion in terms of equipment, and it's probably 20 megawatt of power for the data center, 20 megawatt for a single machine. Imagine that in Île-de-France, in the Paris region, we have close to 100 data center in the region, probably for sure the most and the largest concentration that we have in the country. The average size of a data center is 4 megawatts. So you can imagine that, and the total of Île-de-France is 400 megawatts. So you can see that these new machines are generating a challenge on the current architecture to be able to create new capacities that are amazing in terms of power available, but the second key figure is the density of power per rack. In a cloud data center, you're going to have usually 4 kilowatts of power in a single rack. Good. If you need to bring the new GB200 GPU in a rack, the rack is going to go to up to 150 kilowatts in the single rack. So we are multiplying by something like by 30 times the density of power required in a single rack to be able to host these new GPUs. So we need to invent new cooling systems. We need to invent new power distribution tools. We need to invent the way we're going to host all of that clusters and put that at scale. And all of that, if we don't use new technologies and different way of creating these digital infrastructures, I think the sustainability impact is going to be very big. So this is the way we are trying to limit the impact by leveraging new technologies and new coding systems in order to host that capabilities in a much better way.
Yes, I like very much also the distinction you made, Mihir, between AI, well, I don't know how to call it, the predictive traditional AI and generative AI. And it's interesting what you're saying, because it looks like maybe one AI can help us also with the optimization of the energy for the other AI, which is the big one in terms of energy today, at least. I don't know, maybe in the future the first AI will become big. We don't know. Nobody knows. Again, we have to kind of let the two work together. I mean, we know that there's lots of work from Google DeepMind using traditional AI, if I may use it that way, non-generative AI, to optimize the data center energy consumption for a few years now.
All the new orchestration services to optimize the workloads are AI-based, for sure.
So that's one AI helping the other.
So as AI continues to scale, like we expect or think it'll happen, the need for compute power, for energy, for data centers especially is going to continue increasing. And that, like you said, will require a systemic change in the way we think about infrastructure, both for data centers, GPUs, but also for the energy and water systems that is necessary for these data centers. So let's talk a little bit about the infrastructure and then maybe bounce on that on the higher layers of how inference and training can happen on these types of infrastructures.
Yeah, as I said, the data center of today are huge concrete blocks with a lot of redundant architecture. So we have twice transformers, we have gensets, we have UPS to secure the ability of the data center to keep the lights on. In the future, we won't be able to do that at scale for AI. We need to invent new types of data center that will be much more efficient. We have the chance in this country, as Gilles said earlier, we have a country where the power infrastructure is so stable that we can imagine putting these clusters directly to the grid without putting all of these UPS, all these gensets, reduce the amount of redundancy that are very bad for Scope 3. We need new cooling systems that don't use water at all, because water is perhaps even more important than power in some geographies. So we also need to think about how we can remove the concrete, because with AI, there is one thing that we are 100% sure. The new machine in 5 years' time would be totally different from the one we have today. If we are seeing the rise of these new evolutions in terms of GPUs, take a look at 5 years ahead, behind us. We were really at the beginning of GPUs. In 5 years' time, they have brought into market this new Blackwell GPU. And in 3 years' time, perhaps they're going to be a massive shift in the way they're going to push the boundaries of physical with these new GPUs. So we need to be ready to retrofit and reshape our data centers on a 5 years basis, where basically before we have to do that on a 20 years basis. So the data center of the future has to be flexible, has to be sustainable with the cooling system, and also, if we can, we need to find a way to produce locally the energy versus taking the energy out of the grid. I think, and with these 3 elements, we can imagine data centers that will be much more sustainable than the one we have today.
So recently in the news as well, a couple of days ago, it was announced that Oracle would build 3 SMRs, small modular reactors, to power the data centers in the next few years. At the same time, you're mentioning circular economy, and you had a project with
ENGIE. We are working a lot on trying to find new gas turbine, leveraging biogas and biomass and hydrogen as well, to be able to produce and create energy locally, again, versus getting it out of the grid. So I think it's just the beginning, and we're going to see massive improvement in the way we can produce not only renewable energy, but controllable energy, because in our case, we absolutely need to be controllable.
How do you think about the application layers or the higher layers in terms of model training and inference, both centralized and decentralized with use cases?
Yeah, so first of all, I really like the point you make, which is technology is changing so fast that you have to be flexible. And we don't know what will happen 3 years from now, maybe even 1 year from now, who knows, right? Of course, if we will look back at 5 years ago, we were like even at the very beginning of this. So in that sense, the hope, but of course hope is not a strategy, is that we need to optimize, the fact that this inference training split is happening, as of this week in a sense, which is not surprising in a sense, because you need, again, the inference to be more at the application layer, the AI to think at the application layer specific to the application, the user, and the geography and the market and all that stuff. And the fact that we have this split, the good news in quotes is that suddenly you decentralize the compute need. And this decentralization of the compute need creates new opportunities for optimization, of course.
There is a good example of that, is what we call digital twins. So digital twins is basically a 3D model that takes life. So we are getting and gathering a lot of data very close to where we are generating this data. So basically, if it's a digital twin from a factory point of view, we're going to collect all of the data from the factory directly with a small edge data center. And then we're going to take decisions based on AI locally and gather all the information from all the factories around the world in the core systems and run another AI model during the night to train it and to push back some decisions to make sure that the next day we're going to be able to take decisions from what we have learned from the past for the future. So digital twin is a very good example from edge to core models, because we see that getting data real time to manage this algorithm is very important.
Yeah, just to reflect on digital twins, that's an interesting use case, because traditionally it's been using HPCs, high power computing, to train models based on physical models, equations, and now we're using AI also in our teams to develop real-time computing and simulations, those kind of things, using GPUs that can be used both for HPC and for AI models.
We call that HPC augmented by AI.
Yeah, no, yes, going back, so the technological innovation is very interesting, and let me dare to also put another hypothesis on the table, which is we don't know what will happen on the deep inside the heart of the AI, meaning the math, the algorithm itself. Today we have the transformers. Okay, it's doing something, we don't even know whether it's the most efficient one. Who knows what kind of architecture we'll have tomorrow, which may be 1,000 times more compute efficient. Of course, we will be always hungry for more compute, but don't underestimate the power of math, if I may say that, which is the algorithm design itself. And again, going back to some comments made earlier, this is like the talent for AI that also France has in these days, which can lead to innovations for new architectures that can be a lot more compute efficient. So you have innovations coming from the math itself, to the GPU architecture, hardware architecture, may not be even GPUs tomorrow, maybe something else, depending on the math itself, on the algorithms, to the optimization of the decentralized system, which of course gives lots of new degrees of freedom on how to run these heavy operations.
So there seems to be a lot of interesting parallels between energy and AI. So first, in terms of the kind of building blocks we think about, the electron, the neuron, the token, but also in terms of how consumers become prosumers, producers of energy, producers of data. How do you think about the future of AI? What are the next steps that would be at the intersection of AI and sustainability?
Yeah, that's a very interesting question, and we need quite a very big crystal ball because from what we have seen over the past 24 months, it changes so fast. Then some people like NVIDIA, they have reached the limit of physics, and they have overachieved that. So, and things that we believed 24 months ago that it was not possible. So we don't know. The thing is, we don't know, so we need to be prepared and manage everything we can to be agile and flexible in the way we are building most of our capabilities. AI for tomorrow would be everywhere. It would be in our clothes, in our car, in our house. So we need to anticipate the distribution of AI workloads almost everywhere, and we're going to have computational processes running also everywhere. So, and it's going to be in 2 or 3 years' time. So we won't need to wait for another 10 years. So for me, it's going to happen very fast. We are seeing many use cases going on the play today. So we just need to be careful in the way we are pushing this. And also, we haven't thought about sovereignty and regulations and everything. And we should mention that because it's also very important that we need to keep the data where they should be, and also regulate the market just to avoid a couple of mistakes that we can have made in the past. So yeah, very difficult to predict.
So we're going, you're saying, sorry, that we may go from centralized to decentralized, which
I think it's going to be both.
Infrastructure.
Yeah, it's going to be both. We will need to run at the same time. Let's take Tesla example. They're going to have compute power in the car, and they're going to have thousands and millions of cars getting data for the model to be able to compute the model centrally. So it's going to be really edge-to-core model simultaneously. So there won't be one or other. It's going to be a blend of that.
Yeah, that reminds me of what used to be Internet Zero, this experiment by MIT scientist Gershenfeld. But you had also an example of decentralizing and distributing compute.
Well, I'll actually I'll go on the other dimension. You talked about decentralization of AI everywhere, in your clothes, everywhere, which that's kind of a reasonable future. Who knows, of course. But this also brings the question of decentralization of the energy storage and production in quotes, not production exactly, storage, right? So you mentioned us being as consumers and producers of energy, prosumers, if some people call it. So back to the car examples, whether it's Tesla or something else, we all end up having storage for electricity in our garage, right, in our car. And also in buildings. I mean, you're doing some wonderful stuff also with campus optimization, with energy trade. So think about a future which has a name. It's an idea which is quite old. I always confuse whether it's the Internet of Energy or the Energy Internet, one of the two. But the whole idea is that you have energy stored in a decentralized way. In your clothes, I don't know, probably not, but maybe why not? In your cars, in your buildings, in your campuses, right? So all of us can actually sell energy that we have somewhere to our neighbors. And then you have like this network of objects that run AI, but also have energy stored that can trade with each other. And imagine the amount of optimization in terms of supply and demand matching, where lots of the inefficiency happens, right? When we end up in a world which is a network of things that not only have AI, but also have energy itself that they can trade with each other. With the help of AI, much like AI helping the trading of ad space on the internet, but now it will be the energy internet, where AI will be helping to trade efficiently the stored energy that we have. So that can be a potential future, which probably, again, who knows what will happen, but that's where it seems the direction is going. And even some companies have this energy internet vision as part of their kind of long-term strategy to become like, to provide solutions to coordinate and orchestrate this energy internet future, if you like.
Any final words before we open the floor to a couple of questions, maybe?
No, as we said, there are lots of projects. Technology is moving faster than at any time. It's quite difficult to predict, so we just need to be aware, to be flexible, but also to take care a little bit of what we do, because we can see that the impact of what we do are by far higher than what we have been doing in the past. So we need to be very careful on that.
Well, I usually end by saying I'm cautiously optimistic when it comes to technology. So let me just leave it there, that I think we should just be optimistic, but of course cautious. There's a lot of opportunities to actually leverage this technology to improve things. So it doesn't create problems. Of course it does, but it's probably, if we do it properly, it will actually help overcome the problems it creates and solve more, which is, again, what the AI for the Planet vision is about, from what I understand.
So thank you, Arnaud and Theos, for the discussion. Thank you, AI for the Planet and Artifact, for hosting us tonight. And thank you, ENGIE and MIT Club de France, for supporting us. Maybe a couple of questions from the audience.
Hi, thank you. Thank you very much for a great discussion. I was actually wondering, because you've mentioned some external negative externalities that are being treated, but how about the usage of raw materials, especially for the technology, because it has not been discussed? And the second question would be about sobriety. At what point it's enough of technology in technology? Thank you.
Two very good questions. The raw materials, I mentioned that a little bit in the way we should be designing the future data centers, because we absolutely need to remove a lot of equipment that we are building today for resilience reasons mainly, and remove this because let's take a genset. There is nothing worse than a genset. We're going to use this equipment for less than 200 hours over the next 20 years, and we need to put thousands of megawatts of genset everywhere to secure the power for a data center? Really? So I do really appreciate the question on raw materials, because scope 3 in that world has to change. The second element of that is we need to build the data center with renewable materials. So we have created a design we have launched the first AI data center in the country, Sovereign One, with French funds, and we have completely retrofit existing buildings. So we have either taking retrofit and manufacturing sites, or we can develop modular equipment, based on shelters and containers that we can retrofit as well, because we know we're going to have to change them in 5 years' time. So let's try to take biosourced hardware and find a way to put a real circle in terms of the way we are using the materials, the raw materials, and leveraging that for the future, because it has to change in 5 years' time. So this is for raw material. And second question, sorry, was for
sobriety.
Sobriety. It's all about orchestration and how we do need technology. When do we need technology for real, and when do we need technology for fun, and when do we really need technology to have an impact? And I think for me, we're going to have clearly to educate and to find ways to reduce our technology footprint in some cases, because otherwise we won't get enough power available on Earth to feed the future of AI if we are going in the trend we are going today. So, and there are lots of studies on the market available today that we need to create hundreds of gigawatts of power to feed these new monsters in the next 10 to 15 years. So we won't be able to do that. So the only other point is sobriety, and make a choice on what we should be doing really for that makes sense and have a massive impact.
Yes, again, Karim Jabba from Multiverse Computing. We provide solutions that are based on quantum and quantum-like technologies based on a tensor network model. And we managed to, for instance, optimize AI model up to 93%, reduce the time of inference and training up to 25% and reduce the energy bill sometimes to 40%. I was curious if you had any insight in terms of the evolution of this quantum and quantum-like approach in tackling these specific questions.
Well, I don't really know much about the quantum progress. I follow it as a hobby, if you like. But again, it goes back to what we said before, both the fast technological change and the use of technology to solve the problems we have. Now, having said this, you said 40%, 50%, 80%. I mean, we need to have a couple of orders of magnitude improvement to start having something.
I'm happy to share with you all the use case.
Yeah, and we have been working quite a lot with people like Candela and Pascal on the place of quantum in the future of computing. And clearly, there are lots of use cases and very specific use cases where quantum was going to make a difference, clearly. For many use cases, today the technology is not yet where it should be. So in the next 5 to 10 years, we're going to see for sure what is the right quantum technology that will succeed, that will be able to be productized at scale, and then what are the use cases that we can leverage. Even that, to be able to prepare data for quantum, you're going to need HPC workloads, and to repair or to make them usable, you're going to need HPC at the end of quantum processing as well sometimes. So clearly for me, there is no boundaries between the two. It has to be a mix and leveraging the right computational power that is available when you need it.
Thank you.
We're happy to continue the conversation during the cocktail, or maybe one more question. All right, one more question.
Hi. So the question I had was regarding how we're going to educate and train the people who will be working on the application layer, because when you think about it, there's already a few solutions that are being used to reduce somehow the computing power, like distillation, quantization, to bring those huge algorithms to potentially smaller sizes. And you mentioned at some point edge computing, and what I was wondering is, what is your opinion on, for example, the field of application of SLMs, and how potentially we can train the next generation of AI engineers to think in terms of not only, okay, what's the best technology I can use, but also what is the best technology I can use for incorporating sustainability into it.
So the question of adoption is critical, not just for users, but also for developers and for infrastructure builders as well. Do you have a word on that, Theos? I think you think a lot about it.
Adoption of everything, including a mindset. Basically, you're talking about the mindset in some sense. Of course, as they say, the biggest challenge in technology innovation is change of human behavior. It's not, right, technology adoption and innovation adoption. So, I mean, the answer to your question is there is no silver bullet, of course. One cannot just say training. It's a combination of incentives, training, regulations, culture of the organization, to begin with. So one has to take this through a more systemic, if you like, approach. And this is one of the components, of course, that will be a byproduct of that systemic approach. I think very important thing about systemic change.
Yeah, and we need to, as you said, we need to make sure that when our developers are going to need to take a decision on the type of workloads they have to develop, they need to get access of the best technologies that is available today. And it's changing so fast that keeping them up to date is a challenge. So we have to create an ecosystem that we are going to push to make sure that we continue to inform people on what's going on. We are talking about quantum. We are talking about lots of algorithms available that are perhaps sometimes 10 times less, I would say, consumable than big ones. So things like Hugging Face or people like this, we need to make sure that we push this ecosystem message to allow people and young developers around the world to get access to the technology and make sure that they are taking the right decisions in the way they are doing it. Because on top of sustainability, there is also a cost impact, and sometimes we are seeing a massive increase in the cost of training, and in most cases, it's useless. So that's, I think, something that we definitely need to work on.
Thank you very much.
Thank you.
Thank you.
Thank you.